All right, welcome to the Explainer. If you've been prepping for coding interviews, you have definitely seen this pyramid of numbers before. Today, we are going to completely demystify a true classic, the Pascal's triangle LeetCode problem. We'll break it down so you can solve it no problem.
Okay, so this is what we're aiming for. A beautiful, perfectly structured 5-row Pascal's triangle. Now, it looks simple enough, right? But the real trick here is to write an algorithm that can generate this structure for any number of rows, not just 5.
And that's the real puzzle, isn't it? We start with literally nothing, and we have to build this entire thing, row by row. So, where do you even begin? Well, like with pretty much any coding problem, the secret is to find the pattern.
So let's do that. Let's break it down and find that core pattern. Because once we really get the rules that control how this triangle is built, we can teach a computer to do it for us, perfectly, every single time. The first row, this one's easy. It's always just a single number 1. That is our base case, our starting point. Super simple.
Now moving on to the second row, interesting, it's also made of 1s. A pattern is already starting to show itself. The outside edges of the triangle are always going to be the number 1. Let's call that our first big rule.
Okay, and here's the most important rule. How do we get the numbers in the middle? You see this 2 here in the third row? It's not random. It's just the sum of the 2 numbers directly above it, 1 plus 1. And that, right there, is the core logic. So you see, it all just boils down to this. This one sentence has everything we need. Rule 1, the edges are 1s. Rule 2, every other number is just the sum of the 2 numbers diagonally above it. With just those 2 simple rules, we can build the whole thing.
All right, so we've got the logic down. Now let's make it a little more official. Let's turn it into a repeatable algorithm. Basically, a set of steps that a computer can follow to build a triangle of any size.
The whole process can be broken down into these 5 steps. We'll loop for however many rows we need, and inside that loop, we build a new row. But the key, the real workhorse, is step 4. We calculate the values for our current row by looking at the previous row that we just made.
And this is the key insight right here. To build any new row, all you need is the row you just finished. You want to build row 4? Well, you just look at row 3. The 4 comes from 1 plus 3. The 6 comes from 3 plus 3, and so on. Every single row is completely dependent on the one that came right before it. And this really splits our logic into the 2 clean cases we need to handle in our code. For any given spot in a row, you just ask yourself, am I on an edge? If the answer is yes, the numbers are 1. Simple. If the answer is no, then I must be in the middle, and I got to do a little math using the previous row.
Okay, pattern? Check. Algorithm? Check. Now for the fun part. Let's translate that logic into actual code that can generate a triangle of any size, putting all of our rules together. So here it is, the complete solution in Java. Now, I know what you're thinking. Seeing a big block of code like this can be a bit intimidating. But trust me, if you look closely, you'll see our step-by-step logic laid out perfectly. You've got your outer loop for the rows, your inner loop for the numbers in each row, and the logic to figure out what each number should be.
Let's zoom in on this part. This if statement right here, that's just our rule for the edges put into code. Call equals 0 means we're at the very beginning of the row, and call equals row means we're at the very end. If either of those is true, we just drop a 1 in. No math required.
And if we're not on an edge, the code goes into the else block. And this is our core pattern in action. We just reach into our main triangle list, we get the previous row, that's the row minus 1 part, and then we grab the 2 numbers we need, add them up, and that sum becomes our new number.
Finally, once that inner loop has finished building the entire current row, we just add that finished row to our main triangle list. And that's it. The outer loop then kicks in again for the next row, and we repeat the whole process until we've built all the rows we need.
Okay, so let's say you're in an interview and this very problem comes up. What are the absolute must-know things you need to talk about to show you really get it?
Here's your cheat sheet. First, time and space complexity are both O of n squared. Why? Well, think about it. We have a loop for the rows, and inside that, another loop for the columns. A loop inside a loop, that's a classic n squared situation. The key concept here is dynamic programming.
It sounds fancy, but all it means is we're solving the problem by starting small and using the previous answer to build the next one. And finally, don't forget the edge case. Always mention it. If num_rows is 0, you've got to return an empty triangle.
And to leave you with a final little brain teaser, our approach is fantastic for building the entire triangle. But what if you were asked for just one single number? Say the value at row 30, column 15. Building the whole thing just to get that one number seems kind of wasteful, doesn't it? How would you solve that problem? That's a great follow-up to think about.